Hello class again. I hope you are healthy and safe. We're gonna do another experiment on titration. This is experiment 22. The first experiment 21 was a standardization of sodium hydroxide, and we did that. And if you recall, we have the volume and the molar mass of the KHP and so on and so forth. And from that endpoint, you come up with the molarity of the base. That base that we calculate the molarity or find the molarity through the experiment, we're going to use it for our application today in experiment 22. Right? So what is experiment 22? It's a titration again. Right? So we have to titrate an acid with the base. Again, we need the burette, and we need a flask and a Meyer flask, and then we need the titrant, which is our sodium hydroxide. The difference between the first experiment of sodium hydroxide, we did not know the molarity of sodium hydroxide. This time, we know the exact molarity that you should have calculated. You should calculate it from our experiment 21. Again, now you are familiar with the titrations. We start with a certain volume. It has to be exact. Last time was 0.00. I don't know what Professor Gandhi is going to do today. How will she start with that volume? Then we're going to titrate until we reach the end point. What is the point today for this experiment? We have an unknown acid, a solid acid, unknown. We don't know the molar mass of that acid. So we're going to calculate the molar mass of the acid. It's exactly the opposite what we have done in experiment 21. All right, so we're going to start.
Do you think there's a scale will take this? Okay. We are measuring the empty flask, and it is 96.567. So we can say 96.57.
Okay.
Empty flask.
Empty flask. Empty flask.
96.56.
96.53.
7.
0.37. 0.57.
57.
57 grams. That's the empty flask.
Yes.
We're going to add an unknown acid.
Yeah. They wanted the flask and the solid together. Mass of flask and unknown. So I'm not going to tear it. I will leave that. So I need about 0.5 of the acid. So that will be about 97.4.
The unknown acid, right?
Yes.
Okay.
So about 0.5 gram. $97.1 about. Okay, it's 97.26.
So the
97.26.
the flask and
Flask and the acid.
97. Okay. Empty flask
Plus the unknown.
plus acid,
Unknown.
unknown plus unknown.
Okay.
Unknown
Yeah.
acid is equal
From
97.
here. 97.6.
97.60 grams.
No, it didn't say 0. Okay, 97.26.
97.26. Okay, sorry.
Okay.
Okay.
Now, I'm going to add 50 milliliter of water. Right. 50 milliliter of water. Shake it. Try to dissolve the acid. As we said, if it doesn't dissolve now, when you add the base, it will dissolve. So I will not forget to put the indicator, phenolphthalein, about 3-4 drops. Okay, shake it. And then I'll do the titration, starting from the 0.
No, it's starting titration, right?
Yes.
Okay, let's start titration then.
Be careful to put it inside so you don't get the base outside the flask. And
Okay.
go slowly first, go fast first, and then we'll go slowly after that.
Okay.
If you don't have the indicator, you will not see pink color at all. And sometimes the student said, what is going on here? Nothing happened. All right, let me see here. See, it is going away now, but we are very close. I think that's good enough. It will not disappear. If it disappeared, it is not enough. See?
It has to
Then it
persist
disappears,
for
so I
about
have to add
30,
more
40 seconds.
of the base.
It has to persist.
Slowly shake. I think it will disappear again.
Maybe a drop or two. You have to be very careful now. Maybe 1 or 2 drops. Otherwise you exceed the end point. Maybe it's enough. Probably more than enough.
I think it will stay this time. Yes, it is permanent. Now is
Alright,
the
for the
state.
base,
So that's the end point. So let us take the reading now.
V1 is equal base, V2 is equal. Now give me the volume when we start with. What you start with, 0 also?
10.9.
10.9 V2, right?
Yes, milliliter.
10.9 milliliter.
Correct.
And we start with 0, right?
Right.
0 milliliter, right?
Maybe it need one more drop. It is very light.
No.
But that's
It's
the
an,
best.
an extra point, I think.
Yeah.
Anyways, now, the volume that's used to titrate or to reach the end point with this acid, the known acid, is 10.9 milliliter minus 0. So therefore, the volume is equal 10.9 milliliter of the base.
That's the
Right?
volume, right?
Again, we go back to the same equation. Molarity times volume of the base is equal molarity times volume of the acid. So let me write it down. Molarity, MAVA, molarity of the acid times the volume of the acid will be equal the molarity of the base times the volume of the base. Now it's different than 21. Why? Because this time we do have the MV, we do have the VB by experiment, but we don't have the molarity of the acid nor the volume of the acid. But what do we have there? We have the mass of the acid, the unknown, mass of the unknown, and we don't have the molar mass of the unknown. However, mass of the unknown divided by the molar mass of the acid, the unknown acid, should give me MbVb, the molarity of the base times the volume of the base. All right? Now, all these mass is known because I weighed that experimentally. We don't have the molar mass, however, we have the molarity of the base that we start with and the volume of the base to start with. Then we can calculate the molar mass of the acid would be equal molarity of the base that we did from experiment 21 times the volume of the base that's also from experiment 21 divided by the mass, mistake, sorry. Let me break it down for you so you know what I'm saying. Molarity of the base times the volume of the base times the molar mass of the unknown should be equal the mass of the unknown acid. All right? So therefore, this is known, this is unknown. You divide the molar mass, you divide MbVb, the molar mass, sorry, the mass of the unknown divided by the MbVb, that will give you the molar mass. Very simple, easy calculation. Okay? So we're done with experiment 21 and 22. 22 has all the things.
experiment, in this part, we are going to do
Okay.
from part B, page 270, you are going to do number 1 to number 12, and then you do number 15 and number 16. All right? 1 to 12, and then number 14 and 15. All the result is given to you. So write the calculation, 15, 16, yeah, 15 and 16. Yeah. And do all the calculation. You can answer the question of number 15 and 16. That's what you need to do in experiment number 22. We are not doing part A. You're doing part B.